Good morning, professors. We are from Team 12. I'm Ron, and these are our team members, Jasper, Sean, Zhengwei, and Xiongyi. These are the content that we are going to talk about today. First, I'll be talking more about the introduction. Due to the rise of IoT drives demand for smart homes, these systems surpassing traditional adaptation. They actively learn user behavior for seamless appliance integration. Real-time data analysis enables dynamic adjustments, optimizing the user experience. Our project combines the home assistant for ZB device communication and MQTT hosting. The REST Verify app gathers sensor data such as light, temperature, motion, presence, and using machine learning to learn user patterns for smart device control based on user preferences and data.
Now, I'll be giving a brief overview of our home automation project. Our project is not just about technology, rather, it's about creating a smarter, more efficient, and personalized living experience. So it mainly consists of these features. The first is a user-friendly interface designed to give you, the homeowner, control over your home devices. So this interface is not just a tool, rather a gateway for your home response to your needs, making everyday tasks effortless and convenient. So our next feature goes beyond mere convenience. So it incorporates a machine learning model that intelligently analyzes human behavior throughout the day. So this model learns from your habits and preferences, adapting to your lifestyle in real time.
Hi Prof, I'm Zhengwei and I'll be sharing about the machine learning section in our project. So for the machine learning architecture, we will be using decision tree classifier as we found out that it's efficient on embedded system because of the low computational overhead. It makes it suitable for deployment in embedded system, which requires minimum memory and computational resources. For the log, we will be using a CSV, which acts as a database for us to retrieve the log to train our model. This is the architecture of how our machine learning works. So from the MQTT, whenever the MQTT trigger light on or off status, the subscriber will then subscribe to the topic will then receive the status and then append a new row to the CSV, including the current date time. And from the CSV, it will then feed the data inside the publisher, which we use to train our model for our machine learning. And this publisher also has a predict method, which predicts whether to on or to off at which time based on the log given in the CSV. And whenever it's supposed to trigger on or off status, it will trigger through the MQTT. So to train our model, we need a set of log, but we do not have a real user to start with. So we decided to generate a CSV based on average human. Let's call him John. So average human, John, will usually wake up at 7 a.m. and work all the way to 5 p.m. And after from 5 to 10 p.m., he will then do his own thing at home, which means the green color here means that the light is on. And from 10 to 2, John usually head to sleep. And this gap here, when the light is on, is the margin between 2 a.m. to 2:15 a.m. This is because sometimes John needs to go to the washroom, and after going to the washroom, he will then head back to sleep. And this is the reason why the light is off. So during the time when John is working, sleeping, the light is usually off, and during the time where from 5 to 10 p.m., the light will be on, and sometimes it will then be on around 2 to 2:15 a.m. Next, I'll be showing a demo on how our machine works. To start off with the demonstration, I would like to show you the CSV file that we have generated. So this is based on what we have said previously, based on this time of John's activity. So from this generated using this array, so I set a time between and a status that it should be turned on or off, and then generate it based on the timestamp. So this is not as accurate as a real user data, but this mimics as much as we can of John's or any other average user's activity. So to start off, we'll be running this MQTT sub file, which will be subscribing the MQTT topic called light/status. So to start off with the demonstration, I'll be running this light trigger file. So I have implemented two methods here to have two demonstrations because the actual one does not work as well to demonstrate, because as you can see the current time now is 12:40, and based on the data we have provided or the data we trained on during this time it should be off. So in order for me to demonstrate that you'll be turning on, we have to wait until 2 a.m. So to overcome that, I will be using this demo method later. So to start with the actual one, I'll be showing you the result. So at this time, because previously the last row of the CSV is true, hence it's triggering off. So this last row means that the last status of the light is currently true, which means it's on. So during this time, our machine learning has detected that during 12 a.m. it should be turned off, hence it sets to off. So to show you again, I'll be hard coding this CSV file because our light trigger method checks for the last row, so that it checks for the last row of the CSV such that it would not trigger the same status again through the MQTT because it's unnecessary. So to show you, I will be forcing the last row to be true, which will then it should add another row and turn off because it's turning off the light because it's predicted that way. So as you can see, once I save, it sets to off, and then a new row here has been generated because it has been turned off. So to show you the demonstration using that demo method, we can see that the time now is, sorry, let me stop this. So the time now is 12:42:55. So I'll be putting at 12:44, and then be running this. So what this demo method does is whenever I'll be putting in the time, which is the hour and the minutes, such that during this hour and minute time, so for example for now is 00:44:00, it will trigger turn on status as well as turning off after a time of 20 seconds as we set here for this demonstration. So let's wait for another 15 seconds. As you can see at 12:44 a.m. It has triggered a light status equals to true, which we have also retrieved here because we are subscribed to the topic. So after 20 seconds, it will be turned off again. Here you can see it has triggered false, and the subscriber has also received it. So again, every triggering will be appended to the CSV here. As you can see at 12:44 is true, and after 20 seconds is false. So another way to show you the demonstration, to demonstrate how the machine learning works, is through the Jupyter Notebook. So what this Jupyter Notebook does is we make use of the library called Faker, which fakes a lot of stuff. So in this case, we use it to fake a date time, 10 date time actually. So after generating 10 random date time, we will then use our model to predict whether it should be turned on or off at this random time given. So to show you this, and I'll be putting this here. So as you can see, the randomly generated time is here. So at 1924, which falls in this margin, it should be turned on. As you can see, it's also here. So the actual one is on, and our model predicted that it is on. So at 2157, which is also here, it's supposed to be turned on, and 4:58 a.m. it should be turned off because it's in this margin, and so on and so forth. So as you can see, it's not 100% accurate, but it's 0.99% accurate.
These are the hardware and software components that were used. For the devices and sensors, we use a Raspberry Pi 4, M5 stick, Home Assistant Sky Connect, which is the Zigbee coordinator, a Zigbee plug from IKEA, and a Zigbee motion sensor from IKEA. Next, we have the groove infrared emitter and also a receiver for the IR blaster purposes. And also lastly, we have the Xiaomi temperature and humidity monitor. And for the communication protocol, we used Zigbee, Wi-Fi mesh, MQTT, serial UART, and Bluetooth. For the IoT platform of choice, we used Home Assistant. And as for the machine learning algorithm, we decided to use Decision Tree. Now this is an overview of the whole system. Let's start off with the Raspberry Pi running Home Assistant. It has a Zigbee coordinator connected to it, and it also has an MQTT broker running. I will talk more about Home Assistant in the later slide. Next, we will move on to the devices connected to the Pi running Home Assistant. We have two Zigbee devices, a plug, which is connected to the light and a motion sensor. And the rest of the other devices communicate with the Home Assistant Pi through sending MQTT messages to different topics. Next, we have the user control, which allows the user to control all devices on the network, like its light, AC, and TV. Next, for the Raspberry Pi running our machine learning algo, each time the user turns on or off the light, it will be logged and sent to this Pi, which will adapt and learn the timings the user turn on and off his light. This Pi will also be responsible for issuing commands to turn on or off light based on the learning outcome. Next, for our temperature sensor, we are getting the reading of the Xiaomi temperature sensor using an M5 stick through Bluetooth, and using this data, we will then control the air conditioning. Lastly, we have the mesh network, which routes our command to turn on and off IR appliances like the TV and air conditioning. There's two parts to this mesh network. Firstly, we have one M5 stick, which is subscribed to an MQTT topic receiving message. Upon receiving of message, it will decode which mesh node it is for and send it over to the main mesh node using serial UART. The main mesh node will handle sending out the commands to the correct end node in the mesh network to turn on or off the respective devices. This is the setup of our IoT devices. On the left here, we have the Raspberry Pi connected to the router and a Zigbee coordinator, and this Raspberry Pi is running Home Assistant. And on the right, we have the Zigbee motion sensor here at the back and the Zigbee plug that is connected to a light. This is the close-up of the mesh network that I explained earlier. So over here, we have the M5 stick, which is subscribed to the MQTT topic and is transmitting the messages received serially to the main mesh node. And this main mesh node will then be sending out the commands to the mesh networks. Now I'll be talking more about Home Assistant. In Home Assistant, we have, firstly, the Zigbee Home Automation, which consists of the Zigbee coordinator, motion sensor, and the plug. Next, we also have automation set up to trigger light on and off based on MQTT message, and also to send light on data to the Pi running machine learning. And lastly, we also have the Mosquito broker running on Home Assistant. So for example, we have the topic device/trigger. This is to send commands to control device. This is an example of how the message will look like. First, we have the node ID, and then followed by the command on or off. And same goes for the light. We have a topic called light/status, which we will then send a message containing the word true or false to turn on and off the light. And here's a look at the automations that we have set up in Home Assistant. On the left, I have the automation for triggering light based on MQTT message. It will also check for motion and turn off the light if no motion is detected after 10 seconds. On the right, I have the automation to trigger sending of log to the machine learning Pi when user turn on the light. And now I'll be showing you a demo of the system.
This is the M5 stick that is subscribed to a MQTT topic and sending the message through serial UART to the main mesh node. The machine learning algo will issue the command to turn on the light at 12:24 AM, and if there is no motion detected within 10 seconds, the light will turn off. Next, this is a simulation when there is motion detected. The light will remain on after 10 seconds.
This will be how the machine learning works when multiple light sources are involved. So to start off, we need a data set, a new data set to generate sample data for us to fit a model to test in order for us to test the machine learning. So in order to do that, I have plot out a simple storyboard of a average human, then set up the status of the light by the light ID. So there will be in this situation there are 4 ID. So 1, 2, 3, 4. 1 representing the living room, 2 the kitchen, 3 the toilet, and 4 the room. So after which, this will generate us this CSV, which consists of 3 columns: the light ID, light on, as well as the timestamp. So to see this using this CSV, we are able to use a decision tree classifier, split it into 80 to 20, and then we train the model. So inside this code block, I've created a loop so that I can randomly generate a time and then test the prediction. So as you can see, it's not very accurate, but we can see how this works. So for example, right here, it says 7:22, light 1 is on. So let's steady check. So at 7:22, light 1 is on. 7:22, light 2 should be false. So here, 7:22, false. 7:22, light 3 should be on. So it should be on here. And then lastly, 7:22, light 4, it should be off, hence here. Again, this is not as accurate because our CSV is generated based on hard-coded parameters. So as you can see here, this is 0.99, so we can counter check again. Let's say this. So at 9:26 AM, every light should be off. So in order to counter check, we can check. So 9 AM off, 9 AM off, 9 AM off, and 9 AM off. So that's it for the machine learning for multiple light sources. Thank you.
So I'll be talking about the conclusion part. To sum up the presentation, we talk about the project overview of our project, how we combine home assistant with machine learning and mesh network. Now I'll be emphasizing our project benefits. For home assistant automation, this provides user a way to customize the behavior of the end device by a conditional check. If something happens, it will do something. And then with add-on machine learning, you will learn the behavior of the user, like when does the user actually comes home and stuff. So example like lights, if the user on the lights at this timing, you will learn that the user normally on the light at this timing, and will subsequently alter the behavior of the end device. And for mesh network, the mesh network acts as a communication channel between each end devices and the node. So the benefit of it is that if a node is down or end device is down, another node can act as an alternative route to transmit the delivery of information between the nodes. Next, for suggestion of project to be used in another context, what we talk of is urban farming with machine learning. So the architecture is still the same as home assistant, just removing the home assistant out and adding like water sprinkler, soil sensor, mainly for urban farming. So the same thing, reading sent to the soil sensor, reading will send over the main mesh node, and then the main mesh node will send the operation to the water sprinkler and sprinkle the plant. And then there's also a user which manually sprinkle the plant, send the operation to the broker send to the MQTT serial via MQTT and send to the main mesh node. So with machine learning, you learn the behavior of the user. When does he actually sprinkle the water? Through it, you learn when does the user do it, and then subsequently alter the behavior of when does the water sprinkler actually sprinkle the plant. So this ensures that the user have no physical involvement in altering the behavior of the water sprinkler. So with that, I end the presentation. Thank you.